Hello and welcome. Today's lecture, a fairly hard, ugly looking indefinite integral. I mean, there are some integrals where they're kind of like the very kind of elegant. This one, as soon as I see it, I'm thinking to myself, oh my God, you know, who created this mess? I mean, we got the log of, we got the fraction, the log of x squared plus 1 minus 2 lots of the log of x, in a bracket, multiplying the square root of x squared plus 1 over x to the 4. My first thoughts when I look at this particular one, I'm thinking possibly it's some kind of quotient, because of course, pardon me, from the cough, if I differentiate something that has some kind of function of a log, maybe to some power, because I still have logs in there, then I'm gonna get denominator squared. That's my first thoughts. Could be wrong, could be all kind of like looking at the wrong sort of thing. So what I'm going to do, because I have two logs here, I'm gonna put them together. So I'm gonna say that's the log of x squared plus 1. That 2, I'm gonna write as an x squared. So I'm gonna have that. And then next to it, I'm gonna have x squared plus 1 over x to the 4 dx. And simple as it is, this particular step, it gives me another idea. When I look at this argument, and I look at this, I can actually produce exactly the same thing very, very easily. As follows, of course. Log of x squared plus 1 over x squared. You got to excuse my cough. It's either you have to bear with it, and myself obviously have to bear with it, or I don't record any videos anymore. It doesn't look like this will go away. So I can put the x squared plus 1 with an x squared. Where did that x squared come from? That's from the, I borrowed from the 1 over x to the 4. And of course, if I square it, I can actually write it like this. So, and I still of course have the 1 over x cubed dx. Now all of a sudden I feel a lot better. I'm not saying that this will work, but definitely that looks a lot better. I'm going to use a substitution now. U is, I think possibly the whole argument of the log will work, or the square root will work. I'm a square root man, and therefore probably I will try U is the square root of x squared plus 1 over x squared. And then I'm going to square it, of course, before differentiation. And I'm going to rewrite it as 1 plus 1 over x squared. So what I've done in there, I split the fraction at the same time. Differentiating now with respect to x, 2u du is equal to minus 2 over x cubed dx. Cancel the 2's, and the dx is going to be a minus x cubed u du. Okay, I think this will work. I'm looking at this x cubed. So we have the log of u squared, because of course we have it in this form in here. This we called it u. That was already there. And the dx, a minus x cubed u du. And of course, goodbye my friend, things look a lot better. And simplifying that, we got a minus from here. U times u is u squared, there and there. And this log of u squared, I'm going to write it as 2 log u. So I'm going to write the 2 there. 2 log u. And du. Okay, I'm going to leave the substitution up here because I don't have limits, and therefore I need to go back into the substitution. In fact, I'll put it in some kind of border to remind me. That's what U stands for. Okay, and this is just the standard integration by parts. For me, actually, the integral is actually quite straightforward. Log U to be differentiated, minus 2u squared to be integrated. 1 over u, some kind of grid that I'm using when I do integration by parts. Of course, you can do the integration by parts whichever way you normally do it. For me now, this is actually the product of this column. So it's going to be a minus 2/3 u cubed log u, this bit here, minus the integral of this, the product of this diagonal. So it's going to be a minus 2/3 u squared, because of course the 1 over u will cancel me down. And of course I don't want to have line minuses there. That's going to be, of course, a plus. And the integration finishes now here. I'm going to write this first because it's a plus. So we got 2/9 u cubed minus 2/3 u cubed log u plus c. Probably before we put the substitution, tidy a bit. Pull out the 2/9 u cubed. So that will give us a 1 minus 3 lots of the log of u plus c. We don't actually need the integration by part grid here anymore. And all is left there is to put our substitutions back in. So that is equal to 2/9. It doesn't really matter. This is going to be a mess whichever way we write it. So the u cubed is going to be x squared plus 1 over x squared, looking at the substitution, to the 3 over 2. And then we have a bracket 1 minus 3 times the log of u, where u, of course, is this bit here. And I'm going to write it like this because I want to move perhaps the bit at the front. So what we have in here. So so this one I can write as x squared plus 1 over x squared. And it's the log of u. Actually, nice square rooted. That's okay. Plus c. And we can write this, I guess, perhaps as x squared plus 1 over x squared to the 3 over 2. And write maybe this half at the front as minus 3 times the log of x squared plus 1 over x squared plus c. And I hope I haven't made any mistakes in all of this. This was, I think it's quite a tough integral to crack because it's not that obvious to see where to go with this. It's a total and utter mess. But once you pick up the kind of like compacting the logs and you see this substitution in here, then everything just flows. It becomes kind of like essentially straight maths kind of integral. All the techniques that I use in there are accessible by a straight mathematician. Anyway, I'm gonna sign out and I'm gonna see you real soon. Bye bye for now.